Good morning friends. Here I am uploading a video for electronic and communication engineers. We are going to study right now CRO. We all have know what is the function of CRO. CRO is a device which is used for finding out the frequency, amplitude of the given signal in the form of the waveforms. We can be able to select the type of waveform we have to study, and we can find out its amplitude, frequency through CRO instrument. So basically this is a CRO instrument. We have to first switch on this CRO. This is a switch on button. We have switched on the CRO. For input in the CRO, we have to work on function generator. This is a function generator. We have to switch on this function generator. We have switched on this function generator. Function generator is basically an output, or we can say that input for a CRO that is going to provide the signal to the CRO. Right now you can here see that we have connected function generator to CRO through BMC to BMC connector. This is a BNC to BNC connector for connecting function generator to CRO. Right now this is a function generator. Function generator is used for setting up the frequency you want to study. For example, here you can see that this is a frequency. You can be able to select the amount of frequency you want to study for the selective sine waveform or triangular waveform. Right now this is the frequency. It is 10 Hertz. This is 100 Hertz. This is 1 kilohertz. This is 10 kilohertz. We are going to take the example of 10 kilohertz frequency for determining the amplitude for the sine waveform. Here you can see that this is the sine waveform. This is the button for selecting the form of the wave. This is right now on the sine waveform. We have different type of waveforms. For example, by clicking this button, this is the square waveform, and this is a triangular waveform. This is sawtooth waveform, and this is pulse waveform, and this is TTL. Okay, we have now set the sine waveform. This is the function generator, and this is right now adjusted on sine waveform. We are getting the sine waveform on the CRO, which is cathode ray oscilloscope. What is cathode ray oscilloscope? Cathode ray oscilloscope is an electronic measuring instrument that creates a live and visible two-dimensional graph of alternating electrical signal varying in amplitude with respective time. Here is a short question and answer for you to have a look on that. Okay, these are the types of waveform as I discussed already with you. The sine waveform, square waveform, triangular, alternating attenuations, ECG, exponential fall, AM, FM, and bus type of waveforms we have. Now what we are going to do is we are going for measurement on oscilloscope. We have to find out the vertical measurement for input sine waves. For these calculations, we just switch over this. This is a measurement on oscilloscope, vertical measurement in sine wave. These are the types of sine wave we are getting on the CRO. As you have already seen on the screen of the CRO, these are the sine waves. Basically on the CRO, we can see that this is a reference line. These are the references lines, and if we want to calculate the divisions, then from here we can going to calculate the division. This is complete one division. This is two division. This is third division. And for vertical measurement, this is one division. This is two division. Now we have to find the amplitude for the sine wave. Here you can see that this is a sine wave. This is a sine wave, and this is a one peak. This is the second peak. We have to find peak to peak value. We have to find the peak to peak value. This is the peak deviation. This is the peak deviation. This is the average pressure, and this graph is drawn on voltage versus time. Now we have to find out the amplitude. For that calculation, now we have to find peak to peak value on the sine waveform. This is a sine waveform. We have to find the peak to peak value. For this, we have to press the XY button on the CRO. Here this is a XY button. We have to press this XY button. This will provide the vertical distance between the two peaks of the sine waveform. We have to adjust this waveform. For finding out the peak to peak value deflection, we have to adjust this by this button, Y position button, so that we can be able to find out the exact divisions. I have adjusted this waveform to find out the exact divisions it is getting. Let's count the divisions. This is 1 division, this is 2 division, this is 3rd division, this is 4th division, and this is approximately 4.8. Now this is the calculation part for finding out the amplitude. Here we can see that we have to find the volt per division. Volt per division can be obtained from CRO, which is, in CRO you have to find out the reading which is representing channel 1 reading. This is a channel 1 reading, this is representing 2V, 2 volt. We have to put this reading in the volt per division. Now we have to find the deflection, peak to peak deflection. We have to find peak to peak deflection. We have already find it out how many divisions are there for peak to peak. This is 1 division, 2 division, 3rd division, 4th division, and 4.8. This is 4.5 and this is 4.8. So we have to write it down here, 4.88. Okay, we have to take 4.80 divisions. Now finding out the amplitude. Amplitude is simply volt per division into deflection, that is in division form. Here volt per division reading is 2 and deflection is 4.8 division. This is volt per division. Division get cancelled out and we get the value here 9.6 volt. So basically this is the amplitude. Amplitude is 9.6 volt. Now after finding out the amplitude for the sine waveform, we are going for horizontal measurement input sine wave. This is a practical measurement on oscilloscope for finding out the frequency of the sine waveform. Here we have shown you the sine wave. This is a sine wave. This is a half cycle. This is another half cycle. These half cycles are completing one cycle. This is complete one cycle. This is complete one cycle, and these are the division. This is the one division. This is the second division. We have to see on the CRO. Now finding out the frequency, we have the formula frequency is equals to 1 upon time in second. This will provide the frequency of the sine waveform in hertz. For finding out the time, we have formula time is equals to TV speed into horizontal distance. Now we have to find out the TV speed, which can be directly read from the CRO, and we have to calculate or find out the horizontal distance from CRO. So we have to move on CRO. This is the CRO, this is the sine waveform, this is the half cycle, this is the another half cycle. These are providing full one cycle. So how many horizontal distance deviations are there for one cycle? This is one division, this is second division. So we can say that the horizontal distance is 2 division, and we have to find out the TV speed. We can find out the TV speed from the CRO. This is the TV. This is showing 50 microsecond. Now this is the calculation part. We have to find the frequency. This is time per division. We have directly read the time per division from CRO. This is 50 microsecond. So we are going to write the time per division is 50 microsecond time per division. Now the next is number of division for one cycle. This can be read from the CRT of the CRO. Number of division we have already find out division. This is one division. This is second division for complete one cycle of the sine waveform. So here number of division on one cycle is 2. 2 division for one complete cycle. Now this is the formula for finding out the frequency. Frequency is equals to 1 upon time in second. This will provide the frequency in hertz. We have found out the t beat speed, and we have also found out the horizontal distance. Now 1 upon TV speed, we are going to calculate this. 1 upon TV speed. TV speed is 50 microsecond time per division into horizontal distance. Horizontal distance is 2 division. This will provide the answer in hertz because frequency is in hertz. We have already seen from here. Now the next part is 1 upon 50 microsecond time per division into 2 division. Here we can see that the division will cancel out, and the remaining is 1 upon 50 microsecond time. Time will be in second, and this will be in hertz. Now into 2, this will become 100 microsecond hertz. We have to convert this microsecond. 1 upon 100 into 10 to the power minus 6. This will be converted into seconds. This will provide the result. This will be going to 10 to the power 4 hertz, or we can say that the frequency is 10 kilohertz. This frequency is obtained from calculation, and we have to find out is it right or not. We have to cross verify this frequency which we have found out from the formula. For this we have to go for the function generator. Here you can see the frequency is 10.02. So our answer is right. Now we are going for the measurement of the DC current. If we have DC current, then if we have to find out the deflection DC voltage, then what we have to do is that we have to supply DC voltage. First of all, DC will be provided by this rectifier. Rectifier is a source for DC current. Here you can see that this is a 5 volt output. We have to connect this rectifier to the CRO through BMC to the connector. This is the BMC to connector. Now we have connected the rectifier which will provide the DC current of 5 volt. 5 volt current is supplied to the CRO, and we have to find out by pressing the button. This is the result we are getting. We have to find out the divisions. First of all, what is the calculation involved in this? Let's see. This is the input coupling DC. We have to find volt per division. This can be read out from the CRO from channel 1. You can see that this is the channel 1. Channel 1 is right now showing the reading 2 volt. We can write here 2 volt. Now we have to find out the deflection. Deflection can be seen from the CRO, which is basically a vertical distance from CRT screen. So we have to find out the deflection. We have to go to CRO. Now for finding out the vertical deflection, as I have already told you, this is the reference line, this is the 1 division, this is 2 division, and this is 2.5 division. So the vertical distance is 1, 2.5, 2.5 division. So we can write here the deflection is 2.5 division. This is basically 2 volt per division. For finding out the DC voltage, we have to simply multiply the volt per division into deflection. Volt per division, we have 2 volt per division into the deflection is 2.5 division. Division will be cancelled out, and which will be provide the result 5 volt. So the result is 5 volt, which is of nature DC, direct current.